let's solve a three-dimensional system with row operations. So this is typically how you're going to solve large systems of equations. We have a point, perhaps in three-dimensional space, that satisfies these three different equations. So we're looking for an x value, a y value, and a z value that satisfies all three of these equations at once. Okay, so let's copy down the system. We've got 4x subtracting 3y and adding a z should give us minus 10. We also need 2x plus y plus 3z to be 0. And we also need minus x plus 2y minus 5z to be 17. So as a review, the idea behind row operations, we're going to add rows together and then replace rows with that result in such a way that's advantageous for us. So I'm going to proceed by clearing out that 2x position. So I'm going to multiply my second equation by minus 2. And that's going to give me minus 4x minus 2y minus 6z is equal to 0. I'm not going to touch my third equation. Let's copy it down. All right, now the reason I did that is because now I can add my first equation to my second equation, and that 4x and that minus 4x will cancel my x's. I am then going to replace that second equation with the result. So let's not touch our third equation. And when I add the first to the second, I have 0 x's now. I have minus 5y, and I have minus 5z is equal to minus 10. Right, I'm just adding first to second and putting it right there. All right, now I need to write down the information present in my first equation. 4x minus 3y plus z is equal to minus 10. Okay, so we've cleared out that spot. That's good news. That's exactly what we wanted. I now want to clear out that x value. So I can't use my second equation. There's no x's there. So we use my first equation. Let's copy down that first equation. 4x minus 3y plus z is minus 10. Let's copy down the second equation. And that third equation, I know I'm going to add it to the first equation. So I want to give that x value a coefficient of minus 4. So let's multiply this third equation by 4. We get minus 4x plus 8y minus 20z. And then 17 times 4 gives us a 68. All right. Now let's add our first equation to our third equation because it will cancel our x's. And we're going to replace that in our third equation. So let's do that. We have 0 x's now. Minus 3y plus 8y gives us 5y. Plus z minus 20z gives us minus 19z. And minus 10 plus 68 gives us minus 58. Oh, sorry, positive 58. All right, let's copy down our second equation. And our first equation. Cool. So we've cleared out all of the x's except for the first equation. Now we need to clear out a y value in that third equation. And lucky for us, the coefficients are already what we need to. So we don't need to multiply the equation by any number, right? We can just add the second equation to the third equation and replace the third equation. So I'm going to copy down the first. I'm going to copy down the second. And when I add the second equation to the third equation, I get 0 y's, and now minus 24z is equal to 48. Okay, so we have created what's known as a upper triangular system because we cleared out these two x's and this y value. And now I can solve for my variables and kind of knock them over like dominoes. This third equation, we can solve for z. And once we know z, we can use that second equation to solve for y. And then once we know what y and z is, we can figure out x from the first equation. So the second equation tells us that z has to be minus 2. All right. The second equation, minus 5y, if z is equal to minus 2, this will be plus 10 is equal to minus 10. This tells us that minus 5y is equal to minus 20. Y has to be 4. And then once we know that y is equal to 4, our first equation, 4x minus 12 minus 2 is minus 10. So 4x minus 14 is minus 10. 4x is equal to 4. X has to be 1. So this three-dimensional system has a unique solution in three-dimensional space, the x value of 1, the y value of 4, and the z value of minus 2.